So this is a simple example of KarplusStrong synthesis. This is actually based on a student project from an early version of the class. And it implements physical modeling using a delay line. Now, one of the things I want to point out here is that we're actually using something inside of Max called Gen. And Gen is a special programming subset within Max. And it's very similar to Max in lots of ways, but one of the neat things about Gen, first of all, is that it's sample accurate, so it generates samples on a sample by sample basis. But also, it represents the code as text code, and you can actually have a text code box within Gen and program DSP with a text-based editor, which is actually pretty cool and pretty handy, and I do find that pretty useful. Gen tends to be quite processing intensive. It's more processing intensive than Max is normally, although nowadays our computers are fast enough to be able to handle this for the most part. So it's kind of a fun thing to play around with if you're curious about learning more about DSP and interested maybe in working with a text-based code editor. Gen is certainly something worth checking out. This is how you spell it, G-E-N, like that. So this is the KarplusStrong physical model. And it's pretty straightforward to work with. We have Emily.MIDI key here, and we're going to trigger a delay line. We're going to send a impulse into a delay line, and with the length of the delay line is going to be determined by the frequency of our MIDI note. So our MIDI note comes in here, it gets converted to a frequency, and then sets a delay time. And that delay time in here gets sent to a delay line. So this delay line now has a length of 3.822 milliseconds and a high amount of feedback. And the amount of feedback is determined a little bit by damping and also just by like a constant feedback coefficient here. This could be changed to have a longer decay if we want to, but this model we don't have access to that. But we do have access to is damping, which is a filter. So let's go and play some notes. I'm going to make sure I'm selecting the right audio output. Okay. And one thing you'll notice that it actually sounds not unlike a string. We get to the area of uncertainty here. We're getting low enough that it's kind of not working properly. And get really short delays. So we can't affect the delay time. The delay time is purely a function of the frequency, right? So this is basically representing how long it takes a wave to travel down the length of a string and bounce back. So that's not something we only control by playing our note. We do have two filters. One is a filter on the impulse. So notice that when I play a note, I generate this impulse. And this impulse is the thing that feeds into the delay line. Now I could change the length of the impulse. And that's going to change the character of the sound somewhat. If I make it longer, it's almost more like scraping the string. Which is kind of cool. So the character of the delay line can actually have a really big impact. Let's see what like an infinitely short impulse sounds like. So I would say actually the default setting, which was this, sounds reasonable. So if you can imagine, if you're plucking a guitar string, it takes time to displace the string, and the amount of time that the string is displaced for is going to impact sort of the amplitude and the character of the vibration. So infinitely short pluck doesn't really displace the string very much, right? So a longer pluck will displace the string more and generate more amplitude and also have an impact on the frequency spectrum of the string. So if we go in here, we can change the damping, and you'll see that has a very strong effect on the sound of the string. So almost like you're placing your palm or a piece of felt or something like that on the string. On higher, lower notes, it actually sounds quite nice. This is no damping. This is max damping. And just out of curiosity, let's see what happens if we increase the damping even more than this. So we're limited right now. This number box is limited to these ranges. Let's go ahead and make the limit of this 1. and see what happens when we increase the damping. Just even more. So 1, nothing happens. So obviously that is a hard limit. So that's a lot of damping, right? But it's almost like you're muting the string. Kind of cool, right? Almost sounds like a tube vibrating. So one of the neat things about this is these characteristics that sound like fairly authentic are purely coming from the simplicity of this delay line and a filter in the loop of the feedback line. So that by itself is generating a fairly realistic kind of sound palette. And this is a very simple physical model. So a lot of fun to play around with.